Let's talk about transformations or shifting of graphs. What we want to know is how a graph is going to be affected when we add or subtract a constant value at the end of the equation. Now, to help us visualize this, we're going to use the free online graphing tool at graphsketch.com. First thing I'm going to do is to draw x squared, just a basic parabola. And you'll notice as we switch to the graphing page that graphsketch.com uses a caret key to represent the exponent. So now as we try to draw a picture of our friend x squared, here it is, just a basic parabola. The minimum value of it, the vertex of this parabola, minimum value since it's opening up, the vertex here is at 0, 0. It also goes through the point 1, 1 and negative 1, 1. And we've already talked about that this function has y-axis symmetry, since everything that's on the right-hand side of the picture has somebody that corresponds to them on the left side of the picture. They're the same distance away from the y-axis as each other and the same height. For instance, negative 1, 1 and positive 1, 1, same distance to the y-axis and the same height as each other. Well, now what we want to be thinking about though is what will happen if we take not x squared, but we do x squared then plus a 1. Here's how we'll write that equation. The caret key makes us allows us to do the exponent. So we've got x squared, but then we're adding 1 to it. Now, as I have the picture drawn, you'll see our new picture in red. And let's take a look at what's happened. The vertex of the original x squared here in blue, it moved up by 1 place. Here, the point that was at negative 1, 1, it moved up by 1 place. The point that was at 1, 1, it moved up by 1 place. In fact, every single point that is there has moved up by 1 place. So adding a constant value at the end of the expression moves each point up by however much that constant value says we should do. So then how would I move a picture down? What would we have to do to make it move down? Let's try subtracting 1 to see if that will make it move down by 1 place. First thing I'm going to do is get rid of the one that we raised. Here again in blue is just our friend x squared. And now let's get a new equation that is not just x squared, but it is x squared minus 1. We think this minus 1 at the very back is going to make the picture move down by 1 place. So what I'm anticipating, the vertex, instead of being at 0, 0, will move down to 0, negative 1. The point that was here at 1, 1, we expect it to move down to 1, 0. And the point that was at negative 1, 1, we're expecting it to move down to negative 1, 0. Let's see if that's what happens as we draw the picture. It is. Looks like by subtracting, we moved down. Every point has moved down by however much the constant value at the back said for us to go. So by subtracting a constant value, each point moves down by that much. Now here's the key for us to keep in mind. A number added or subtracted at the end gives us a vertical shift. It either moves the picture up when we've added, or it moves the picture down if we've subtracted. Vertical shifts come from adding or subtracting at the very end of the function. So how am I going to make a horizontal shift? Let's think about how that could happen, how we could move a picture either right or left, and we're again going to use x squared as our example. To make a horizontal shift, we're going to either add or subtract a constant value within some grouping symbol. Now, since we're using x squared as our example, let's start by having a -1 inside parentheses. So we're going to do x minus 1 squared. Let's go to our graphing page. Here is our friend x squared, points at 0, 0, 1, 1, and -1, 1 again. Now, here is our equation that we want to try to represent. We've got x minus 1 in the grouping symbol. The caret key is our exponent. And let's let it draw a picture for us in red and see how it looks. As the picture comes up, we'll notice that the entire picture has shifted to the right. The vertex here at 0, 0 has now moved over by 1 place. The point that was here at -1, 1 has moved over by 1 place to the right. And the point here at 1, 1 has moved over 1 place to the right. So even though it seems a little bit backwards, having that -1 in the parentheses actually moves the picture to the right. If we want to move a picture to the right, shifting a picture to the right, we subtract within the grouping symbols, even though that might seem a little backwards to us. So then, how do you think we would move to the left? Let's try adding and see if that'll do it. So now, I'll do +1 within the grouping symbols and see if that moves us to the left. Let's go back to our graphing page. I'm going to first take away the picture that we shifted to the right. Here's our friend x squared again. And now let's see if we can get us a picture that will go to the left. By adding 1 inside the grouping symbol, everybody's going to move left. Look at your vertex. It was at 0, 0 on our original x squared. It's now moved left by 1 place. The point that was here, it's now moved left by 1 place. And the point that was here, it's now moved left by 1 place. Every point has moved left by 1 place. So now when you add something in the parentheses in any kind of a grouping symbol, the effect is that it moves your picture to the left. So if you're going to make a horizontal shift, you either add or subtract within the grouping symbol. Want to move right? Subtract. Want to move to the left? Add within the grouping symbol. We've seen that we can do vertical or horizontal transformations for x squared, but I wonder if it'll work with other shapes. For instance, here I've drawn the square root of x. The way that our graphsketch.com represents square root of x, you type in root, whatever you're trying to take the root of, and whatever type of a root it is. So since a square root, our index is 2. That's the way you're going to type it in. So putting root and x and 2 gave me the square root of x picture. Well, let's see if we can make a vertical transformation to it. Let's do the square root of x, and then let's add a 2 back at the back. That adding a 2, what's it supposed to do? It's supposed to move everybody up by 2 places. So now let's see if it does. When I do that, yes, it did. Even though we've changed the equation, we're working with a different shape, this vertical transformation still works. By adding a constant value to the end, it moved everybody up by however much that constant said. Since we had a +2 for the constant value, every point moved up by 2 places. Let's take that one away. And now let's think about a horizontal transformation. Let's see what happens if within our grouping symbol, so you'll have to imagine a square root of x minus 1. All of this is up under that radical. All of this is being grouped together up under that radical, and we're taking a square root of it. Let's see what that does to our picture. we're expecting for it to move right by 1. Because remember, a minus sign within the grouping symbol moves everybody to the right. And look at there. It did it just like it was supposed to. This point moved right by 1. That point moved right by 1. So just like before, horizontal and vertical shifts work even with a square root. They'll work with any shape that you draw. But one other thing that I'm curious about, can we do both a vertical shift and a horizontal shift in the same problem? Let's see if we could do that with this equation. Now, what I've got here, the 2 at the back, that's saying that it's a square root. Imagine that this x plus 2 is within the square root symbol. And then on the outside, I've got a minus 3 back here on the outside. So now let's anticipate what's supposed to happen here. The minus 3 is supposed to take everything about the picture down by 3 places. The plus 2, that's supposed to take everybody to the left by 2 places. So I want to go left by 2 places, down by 3 places. Let's draw our new picture. Here goes our new picture, and now let's see what happened. The point that was here moved left by 2 and then down by 3. So vertical and horizontal transformations can occur within the same problem. Whatever is added or subtracted at the very end, that moves you up or down. Whatever is either added or subtracted within parentheses or grouping symbols of any kind moves you to the left or to the right. Careful with those horizontal transformations. A plus sign moves you left, a minus sign moves you right.